Hello everybody and welcome to section 8. This is the last section in this training course and it will be the practical part of it. Now it's the time to have some practice, and that's why we will model what we call Stirling engine. We will start with the modeling, then we will go to the assembly design, and after that we will have a quick look at the detailed drawing. Let's try to understand the principle behind Stirling engine. So whenever we have a heat source somewhere here, it heats a gas inside, and this gas expands. When this gas expands, it pushes this piston up, something like this. Then, when the atmosphere here is colder than the atmosphere here, this piston will go down once again, and this forms one stroke of this engine. Now, we have a heat source here, which means the gas will keep expanding, which means this piston will go up all the time, and then it contracts here on this plate, which means it will go down. And that's why we added this displacer cylinder. So the motion we will have would be something like this, and if I turn this into transparent, here you can see the power piston. And this is how this engine works. In the next video, we will talk about the displacer cylinder modeling. We will start with the displacer cylinder modeling, which is this plate, this cylinder, and this plate. We will start with a new part, and we need to start a sketch on the top, and here we need to draw a circle, and this diameter should be 120. And now let's extrude this to 5 millimeters. Now we need to place some holes. Before doing so, let's specify the location of the hole by having a sketch here. So I will have a line, and another one, and this angle should be 30, and let's set this to 55, and I just need to place a point here so I can use it as a reference of the hole I will create. Now it's better to create the holes using the hole wizard. Now select hole wizard, and I need to select a hole. I will go to the DIN standard, and here I will select drill sizes, and for the diameter select phi equals 5. Make sure to select through all, and now let's select positions, 3D sketch, and simply snap to this point here. And the hole was created. Now we need to pattern this hole. That's why select circular pattern, and for direction 1 select this face. So the center line of this cylinder will be the axis of revolution, and I need to create 6 holes. And for the features, open this menu here and select the hole. Make sure to set this to 360, and now we have these 6 holes. Now this part is done. Let's give it a color. So expand this menu here, then click this arrow, and for this color here, select appearance. Make sure part is selected, and let's set this to red, for example. Let's hide this sketch, and now let's save this part, and make sure to give it a proper name. So in this case, we will call it displacer cylinder bottom plate. This is a descriptive name, so displacer cylinder bottom plate. Save it, and now let's move to the other part, which is this cylinder here. So let's create a new part, and start a sketch on the top. And here, let's draw a circle. This diameter is 100 millimeters, and we need an offset with 2 millimeters. And then select this circle and make sure to reverse the direction. And here, let's extrude this to 20 millimeters. Hit OK. And the same way, let's give it a color here. So select Appearance. And for example, let this be, let's say, green. And I want to make it transparent, so simply just click here. Now hit Save. And let's call it Displacer. Cylinder. Cylinder. Now, two parts are ready. Now we need to create this upper plate. Now, if we have a lock here, this plate and this one are almost the same. The only difference here is that we have extra holes. So basically, the diameter is the same, these holes are the same, and the thickness is the same, but we need to add these holes. So there's no point of repeating the whole thing again, and this is a new technique. We should use this plate. Open the Displacer Cylinder Pattern plate, and here select Save As, and instead of bottom plate, I will call it upper plate. Now I have another copy of that plate, so now I just need to place the holes. To do so, let's select this face and then start a sketch, and I will turn this into Hidden Lines Removed. And here I need two big holes. The first one is at the center, and this diameter is 10 millimeters. And the second one is somewhere here. This diameter is 12, and the distance between them is 24, and they are horizontal. Now we need to create some reference for the rest of the holes. So here I will draw the square and make sure to select For Construction, because I don't want it to affect the cutting. Then set this to 22 and make both of these equal, and then once again select Center Rectangle, and let's draw another one here just randomly, and make sure to select For Construction and set these dimensions. Now set this point with this one to be horizontal, and the distance between this line and the origin is 25. So now I will use these corners as references to create some holes. Now finish the sketch and go back to Shaded with Edges and select Extruded Cut, and this time select Through All. Now we no longer have the sketch here, so make sure to open this feature and then show this sketch. Now select Hole Wizard and make sure to select Hole, DIN, drill size, and this time select 4 millimeters. Through All, and for positions, 3D sketch, and you just need to snap to this point, to this one, to this one, and so on. So basically 8 holes. Once done, go back to Type, make sure everything is correct, then hit OK, and hide this sketch once again. We just need to change the color now, so select Appearance, and let's say we need this to be yellow, then hit OK. So now we have these ready. Now let's introduce a new concept, which is sub-assembly. In the assembly section, we saw that we can insert parts into the assemblies. Now what we will do is that we will create a small assembly that we call sub-assembly, and later on we can insert it as one unit in the assembly itself. In other words, we will have a big assembly, which is the main one, and we will have smaller assemblies, which are the sub-assemblies. So now, select Make Assembly from Part or Assembly, and we have these files. Make sure to go to Browse and select Displacer Cylinder Bottom Plate. Once you have it, hit OK, and I need this plate to lie in the center of this file. So right-click here and select Float, and then select Mate, select the origin, open this part and select the origin, and make sure Align Axes is selected, then hit OK. And here I have a fully defined part. Now, let's insert the cylinder, which is this one. Now, I want a mate, which is concentric. So basically, select this face and this one, and make sure to select Lock Rotation. Now, there's only one small problem, which is that this cylinder moves up and down. So we need to eliminate this motion. To do so, select Mate once again, Coincident, and zoom to this face and this face. And here we have a fully defined assembly. Now, let's insert the third part, which is the upper plate. And here we need concentric. Select this face with this one. And now you need to drag it a little bit here. And let's select another concentric, and then select this hole with this one, for example. Now we still have 1 degree of freedom, which is this motion. So we need to eliminate this motion too. So select Mate, Coincident, select this lower face with this upper one. In some cases, you will not have a space to select these faces. So you simply need to drag this a little bit here, and then select the mate. Now we have this assembly, and let's save it and call it Displacer Cylinder. Then hit Save, and here we have our first sub-assembly. Next, we will create these parts, and we will add them to the assembly. Displacement Cylinder Guide Modeling and Power Cylinder Modeling. Now we need to create these two parts. Let's start with a new part file, and here we'll start a sketch on the front, and then we need to draw the following. We need to define a distance here. This is 3 millimeters, and then this is 6 millimeters, and this height is 6 millimeters. We need to make this line vertical, and then these two heights are equal, and then these two segments are equal too. We need a center line, and then we need to finish the sketch, and let's revolve this about the center line, then hit OK. And now let's go to Appearance, and let's set this to, let's say, blue, for example, and then save this part, and let's call it Displacer Cylinder Guide, then hit Save. And now let's move to the other part, which is this one. So we need to create a new part, and then on the top, let's draw a circle, and this diameter is 40. And here we need to create another circle, and let's set this to 18. and then this distance is 24. And we need to set these to be horizontal. And then we need an offset with 1 millimeter, and select this circle, then hit OK. And now we need to convert this one and this one into construction geometry. Now select Trim Entities and make sure to trim this part, and this one, and this one. Here we need to create another hole, which is 12 millimeters. And we need to define a square, which is 22 millimeters. And we will use it as a reference to create some holes. So select all of these and set them to be for construction. And don't forget to close this sketch by selecting 3-point arc, snap to this point, snap to this one, and then snap to this. And here we have a closed sketch. Now finish it, and let's extrude this to 3 millimeters. Make sure to show the sketch, and then select Hole Wizard, and here keep the same options. The size is 4, go to Positions, 3D Sketch, and let's start placing the holes. If it doesn't work, simply place any 4 holes, and when you're done, click here to exit this command, and then select this point, hold Ctrl, select this point, and notice that we need them to lie on the y-axis, so select along y. Now they are on the same level, and you need to do the same with this one here, and this one here, and this one here. Now, if you go back to type, make sure it's through all, then hit OK. And here we have the holes created. Now, let's hide this sketch, and this time select the front, and switch the view to Hidden Lines Visible. Then pick a line. Let's snap to this point here. And let's draw the following. Now I want this to be 5.5, and then select these points and make them vertical, and you need to do the same here. And you need to set this line to be horizontal, this one to be horizontal, and this one to be vertical. And finally, you need to set all of them to be equal. Now the number is 1, 2, 3, 4, 5, 6, 7, 8. So we need another one here. And now we should close the sketch. This height should be 25 millimeters. And we need to set this one with this one to be equal. And here we have a fully defined sketch. Now we need a center line. And then finish the sketch and select Revolve. Make sure it's 360, then Merge Result is selected, then hit OK. And let's go back to Shaded with Edges. Now, let's go to Appearance. And here, let's pick green, for example. Let's save this. And we should call this Power Cylinder. So far we created the displacer cylinder, we created this part and this one. Next we will create the support. Support modeling. Now it's the time to model the support. We need to start a new part file, and then we need to start a sketch on the front, and here place a center line, and let's set this to, let's say, 100 millimeters. Let's start with a line somewhere here. So let's adjust this height to 85, and then merge these 2 points, and let's set this to 8 millimeters. Then let's draw another line here, and then this distance should be 21.5. Then we need to draw this profile. This distance here is 12.17, and this one is 8.5, and this one is 8. And then we need to draw the symbol profile. This distance here is 20, and we need to set these 2 lines to be parallel, and then we need to select mirror entities, and we need to mirror everything about this center line. Then we need to draw a circle here, and this distance should be 10, and this diameter should be 12. Finally, you need to draw a line here, and then let's set a distance between this line and this one of 25, and then let's offset this with 5 millimeters and select this line and make sure to reverse direction. And now select trim entities, trim this part, this one, this part, and this one. And here we have a fully defined sketch. Finish the sketch, and now let's extrude this with 6 millimeters. And set it mid-plane, then hit OK. And now we need to place some holes here, so select this face and start a sketch. And here I will place 2 points. And now I will set the points with the origin to be horizontal, and I will set a distance between them of 50. And finally, I need them to be symmetrical about a center line here, so pick a center line. To make them symmetrical, you need this line to be vertical, then select this point, hold Ctrl, select this line, and select this point, and here you will find Make Symmetric. Now, finish the sketch and go to Hole Wizard. Keep the same options. The diameter is 4, positions, 3D sketch, and simply select this point and select this one. Make sure it's through all, then hit OK. And now we need to give it an appearance. So select Appearance, and let's go here to Appearances, and under Metal, for example, you'll find Galvanized, and let's keep it this way. Now let's save this and call it Support. Now let's create the master assembly file. And here we need to insert this time the sub-assembly, which is the displacer cylinder sub-assembly. Here, as you can see, we have the sub-assembly inserted, and it's treated as an assembly inside the assembly file. If you open here you will find that we have these parts. Now we will treat it as a single part. So select float and select mate. We need to select this origin with this one. Then hit OK. Then rebuild. Now let's insert the rest of the parts. So insert component, browse, and I will increase this so I can have this preview. I will need the displacer cylinder guide, and this will lie here. So select mate, concentric, this face with this one, and make sure to lock the rotation, then hit OK. Now drag it here and select this face with this one. And here we have it. Now it's fully defined. Let's go to the other component, which is the power cylinder. Select it, and we need to select mate, concentric, select this cylindrical surface with this one here, then hit OK. Don't lock the rotation because we can use the holes we have here. Now select this hole and select this one. They will be concentric, then hit OK. And finally, we need to select this face with this face to be coincident, then hit OK. And it's the time to place the supports. So select insert, and we need the support. Now drag it a little bit here and select mate, concentric, select this hole with this one, and now once again select this hole with this one. We still have 1 degree of freedom, which is this translation, and here you can select this face with this one, and we have a fully defined assembly. Now you can repeat the same steps to place this one, or you can pattern it, or you can copy it with its mates. This is a new technique. So when you select support, right click, you will find copy with mates. So we already defined the 3 mates: concentric, concentric, then coincident. So click this arrow. So for the first concentric, which is represented here, I want it this time to be here. And for the second concentric, which you can see here, I want it to be here. And finally, for coincident, I can repeat the same because I will use the same surface. So simply select repeat. Then hit OK. And now hit cancel. I still have a fully defined assembly file and both supports were placed. Now, if you're confused with this method, you can insert it once again and apply the mates. But if you can practice this method, it will save you a lot of time. Next, we will talk about the crankshaft. Crankshaft modeling. Now, we will create this crankshaft. This cylinder will be a separate part, and this body will be a separate part, and so on. So we will create a sub-assembly, and then we will add it to the main assembly. So let's start with a new part file, and then start with a sketch on the front with a circle. This diameter is 6, and then let's extrude it to 20. So I will save this and I will call it crank 1. So the naming will go from here up to here. So this is crank 1, 2, 3, 4, 5, 6, 7, 8, 9. Now these 4 parts are identical. So it will be crank 2 and 4 and 6 and 8 are the same. So let's create a new part file, and here on the front we need to create a center rectangle, and this should be 16 by 8, and here we need to create 2 holes. And now set a diameter of 4 and make these 3 points horizontal and make the 2 circles equal. Finish the sketch, and let's extrude this to 2 millimeters. Then hit OK. Let's give this an appearance. And let's save it. It will be crank 2 4 6 8. Now let's go back to the original model. Now we have these 2 cylinders and they are the same. So 1, 2, 3, 4, 5, 6, 7. So 3 and 7 are the same. Now we have this cylinder, which is the 1, 2, 3, 4, 5, the 5th part. And finally, we have this part, which is number 9. Now, let's talk about the assembly of this crankshaft. We'll start with a new assembly file. And here we need to insert crank 1. Here, I will set this to float and then mate. Select this origin with this one. I forgot to assign a appearance, so I will open this from here, open part, and simply drag this, and that's it, an appearance. And for example, let's choose this one. Save. And here we have it. Now, insert component. We need crank 2, which is this one. And here, select mate. We need to set this hole with this cylinder. And obviously, we have a problem here, but it's not a big deal. Hit OK. And then we need this face to be coincident with this one. And I don't want this rotation, so I will use the top plane here with this face, and they are parallel to each other. Now, this is a good application on the interference detection. If we go to evaluate under interference detection, then calculate, we have this interference. So the solution is easy. We need to modify this diameter. So you need to open this part, and here open this sketch, and instead of 4, let's set this to 6 millimeters. Then hit OK. Save it, and then go back to the assembly. If you check the interference, everything is fine. So 1, 2, now we need to insert crank 3, which is this one, and we need to do the same. So select concentric, this face with this one, but make sure to lock the rotation now, and then select this face with this one, and here we have it. Now we need crank 4, which is this one, and now you can select mate, concentric, this one with this one, don't lock the rotation, this one with this one. The reason why we don't lock the rotation is that it takes the current position and it locks the rotation, so in some cases it won't be 100% parallel with this face, and that's why we need to add a mate here, parallel, which makes this face parallel to this one, and this way we are 100% sure that there is no difference between them. Now we need to insert 5, let's do the same. You can lock the rotation here, and then this face with this one. And keep double checking your work, we have a fully defined. So now if we go back to the master model, I have a 90 degrees offset between them. So now I need to have this with 90 degrees. So if I go back to this file here, and then I need this part. Here, select mate, concentric, this one and this one. Don't lock the rotation, this face with this face. And now let's select parallel and select this face with this one. You can flip this orientation. So now when these faces are parallel all the time, I can make sure that I have this phase, which is 90 degrees. Now I have a fully defined. Then 1, 2, 3, 4, 5, 6. Now I need 7. Here I forgot to lock the rotation, so simply open the mates. And notice whenever we lock the rotation, we have this dot inside, and whenever it's not locked, we have this symbol. So edit this feature and select lock rotation. Now, once again, and finally, the last item is crank 9. And here we have the crankshaft ready. Now, I need to save this subassembly, and I will call it crank sub assembly. Then hit save. Next, we will model the bearing, and we will attach the crankshaft to the master model. Bearing modeling and the crankshaft attachment. We will represent the bearing we have as a cylinder. So start a sketch on the front, and let's draw 2 circles. This diameter 6 millimeters, and the other one is 12. Now extrude this mid-plane and set this to 6 millimeters, then hit OK. And let's give it an appearance. And then save it. Let's call it peering. Then hit save. And now let's open our master model. So now I need to place the peerings. So I will go to Assembly, Insert Component, and here insert the peering. We need this to be concentric between this face and this one. And then we need to select this face with this one. Notice that we need to lock the rotation, so I will edit this mate and will set this to lock rotation. Now I need another one here, so simply I will right click bearing, then select copy with mates. Then for the concentric it will be the same because this axis here is the same, so I will repeat this mate. And then for the other mate, I need to select this face. Then hit OK. And here we have them attached. Now it's the time to attach the crankshaft. So let's insert another component. And here we need to select crank. Now, before placing this one, I want you to go to Evaluate, Measure, and make sure that this dimension here is 20. So the 20 will be on this side, which is closer to the edge. So once again, select mate, and then select this cylindrical surface with this one. But notice that we need to flip this direction, so select aligned. And here I need the rotation, so I won't lock it. Hit OK. And then select this face with this one. Then hit OK, and once again. Now, if you try to rotate this crank, it rotates. And this is what we need in this case. Now, hit Rebuild. And save the file. Next, we will talk about the displacer piston modeling and the power piston modeling. Power and displacer pistons modeling. Now we need to model this part and this one. So we will start with the power piston, which is this part. We need to create a new part file and then start a sketch on the front, and then draw a center rectangle, and this should be 2.5 and this should be 4.5. And now pick a 3-point arc and then set these to be coincident, and here place a circle, and this diameter should be 4. Now finish the sketch and select extrude. First of all, for from, select offset and set this to 2.5 millimeters. And for selected contours, you need to select this part and this one, and you need to set this value to 1. Now select mirror, and for the mirror face, select the front. And for bodies, to mirror, make sure to select this one, then hit OK. And we have a problem because merge solids is selected, so because we don't have anything that connects these two bodies, that's why you need to remove this option, then hit OK. And here we have them. Now select this face and simply pick a corner rectangle, snap to this point, and draw something like this. Then make these 2 points coincident, and we need this value to be 0.5 millimeter. Finish the sketch, then extrude this and set it to through all and make sure to reverse the direction. And here I want merge result to be selected because I want to have only one body in the end. Now select the right plane and start a sketch there. And here, let's draw such a profile. Then select this line and this point and select make midpoint. After that, set this line to be vertical and this width should be 2 millimeters and this height should be 3 millimeters and this height should be 6 millimeters and this distance should be 6 millimeters. We need to apply some fillets, so select fillet and set this to 0.5 and then select this corner and select this one, then hit OK, and we need to select this one too. Now once you're done, finish the sketch and select revolve, and for the axis of revolution make sure to select this line, then hit OK, and here select fillet, set it to 0.1 and this time select this edge. When you create the revolve, make sure that merge result is selected. Now we need to give it an appearance, so go to appearance and here let's keep it white, and this will be the power piston, so hit save and call it power piston. Now if we have a lock here, the displacer piston is almost the same. The only difference here is that this part is longer and we have this cylinder inside. That's why we should use the same part, but we can modify it. Now let's open the power piston, and here I will save as, and instead of power piston let's call it displacer piston. Now make sure that you have the displacer piston open. Once you have it, we can modify it. Now we need to open this revolve, and then I need to delete this dimension, then pick another dimension and define a distance of 36. And here I need to delete this radius, so select it, then hit delete, and select these 2 points, and then select merge points. Finish the sketch and start a new one on this face, and let's draw a circle from the origin and set it to 95.5 and then extrude it to 0.5 millimeter and make sure that merge result is selected. And here let's apply a fillet of 0.25 millimeters and select this edge. So this is the displacer piston and it's ready. Next we will create the connecting rod and we will create this sub-assembly. Connecting rod sub-assembly modeling. Now we will create this sub-assembly. Let's start with a new part, and here start a sketch on the front, and we will start with a center rectangle. I want this to be 5 millimeters and this to be 15 millimeters. And now let's pick a corner rectangle and draw something like this, and let's draw a center line here. Select this line, hold control, this one, and then make symmetric. Now this length is 45, and this width is 4, and here pick a circle and snap to the midpoint, and let's set this diameter to 5, and we need another one and set it to 6 millimeters. And I need another circle here, snap to the midpoint, and set this to 6 millimeters. Once you're done, finish the sketch and select Extruded Boss, and now select this contour and this one and this one here. And don't forget to select this one. Now, make sure to set it to 4 and mid-plane, then hit OK. And here we need to apply some fillets, so select Fillet and set this to 4. And let's select this one and this one. Actually, we need to reduce these. And then, once again, select Fillet and set it to 10 millimeters. And select this edge and this one. Now we need to place 2 holes here. So we need to place a midpoint line. And we need to define this distance here, which is 2.25. You can turn this line into construction geometry. And now let's go to Features, Hole Wizard. And I will select Hole, DIN, and I will set this to 2.5. And for positions, 3D sketch, simply snap to this one and snap to this one, and go back and make sure it's through all, then hit OK. Now let's rebuild this part, and now we need to create the other part here. So let's save this, and let's call it Connecting Rod 1. Let's give it an appearance. And we need to save it once again. Now let's create a new part. And on the front, let's start with a center rectangle. And this should be 5 by 15. And the same way, we need to create a circle here, snap to the midpoint, and let's set this diameter to 6. And now, let's extrude, and make sure to select this contour, mid-plane, and this should be 4 millimeters. Hit OK, select this face, start a new sketch, and let's draw a midpoint line. Then we need to define a distance here, which is 2.25. Now finish the sketch, and once again go to Hole Wizard, and the size is 2.5, positions, 3D sketch, and select this one, and select this one. Then this is ready. We need to give it an appearance. So select this appearance, and notice that here we have paste appearance. So the last appearance you used is copied to the background, so you can use it once again. Now you need to save this, and we need to call it Connecting Rod, but this time 2. We need to save it. And now let's create a sub-assembly. So we'll create a new file, assembly file. And here we have Connecting Rod 1. We need to place it, and the same, we need to make it flat. And here, once again, select origin and select this origin. Then we need to insert the second part, which is connecting rod 2, and simply select mate, concentric. We need this hole with this hole. Okay, and now we need this hole with this one. And finally, we need this face with this one. Now we need to create a cylinder that connects these. So we need to go to Evaluate, Measure, then select this face, and select this one. And the distance between them is 10 millimeters, and this diameter is 2.5. So now let's create a new part. And on the top, we need to draw a 2.5 circle. And here I need to extrude this to 10 millimeters. And I will give it an appearance. And I will call it Connecting Rod Pin. Now let me go back to the assembly I created, and here I need to insert this pin, and then select this face with this one, and let's lock the rotation, and this face with this one. And instead of repeating the same thing, this time I will select this part, then copy with mates, and here for the concentric I want this face, and for the coincident I need the same one. If we have a section view, everything is correct, and we can double check the interference. Now if you go back to the master model, we need some kind of bearing here. So we need to model bearing, and that's why we need to measure this diameter, which is 5. So here, let's create a new part, and on the front, we need 2 circles. The first one is 4 millimeters, and the second one is 5. And we need to extrude this to 4 millimeters and make it mid-plane. Hit OK, and let's expand this, and we will give it the same appearance, and we will call it Connecting Rod Bearing. Once you save it, go back to the sub-assembly, and we need to insert this bearing here, and select mate, concentric, this face with this one, and let's lock the rotation, and then we need to select this face with this one. So here we have the connecting rod ready. Let's save this sub-assembly. And let's insert it in the master model. Here we need to insert the cylinders. We need to insert the power piston, which will be here. And now we need to have concentric between these 2 faces. And notice that I need this motion this time, so I don't want to eliminate it. And now I will insert the sub-assembly, which is the connecting rod sub-assembly. Now, there's a very important trick we should learn. I want the connecting rod to lie in the middle of this segment. There are many ways to do it. You can calculate the distance and select coincident. You can use the datum planes, but alternatively, we have a very nice tool in the mates we will use now. First of all, we need a pin connection or a concentric. So select this face with this one, and they will be concentric. At the same time, I want another concentric, but this time here. If this is confusing for you, select this part and then select hide. Now select mate, concentric, then select this face and select this one, and they will be concentric. Now you have two options. The first one is to make this in the middle of this segment, or to set the connecting rod in the middle of this piston. To do so, I'll go to mate, and here you will find advanced mates, and here you will find width. Basically, you will need to select 4 faces. The width selection, for example, if I select this face and this face, and now I will select this one, and what will happen is that these 2 faces, which I will select later, will be sat right in the middle between the faces I selected earlier, these ones here. Let's see this. Now the first selection is done. Now it's the time to the second selection. So select this one and select this one. And here, as you can see, it's right in the middle. Now, we have a problem here. If we go to evaluate, to interference detection, as you can see, we have some kind of interference here, and we need to solve this problem. The solution is easy. You simply need to open this part, and here you need to open the first sketch you created, and we need to increase this to 3.5, then hit OK, and let's see if this solves the problem. Don't forget to save, and now we have this distance, and that achieves the purpose. Now, let's show the cylinder once again, and let's try to move this. If you drag this here, as you can see, we have this kind of motion. Now, to view it better, I will drag this, select this item, open this menu, and make it transparent. Now, if you try to drag it, you can see the motion. One part is missing here, which is we need a pin. Now, go to measure, select this face, and select this one. And the distance is 7, and the diameter here is 4. So, select the front. Let's draw a circle. And this is 4 millimeters, and extrude it to 7 millimeters, and mid-plane, and here let's paste the last appearance, and let's call it connecting rod pin 2. Now you have two options. You can insert it here, or simply you can open this sub-assembly and you can insert it here. Connecting rod pin 2. Now the color will be confusing, and that's why I will change this color. So I'll go to connecting, or can drag this, open this arrow, and here select appearance, and I will set this to red. And I will select mate. I want concentric. I want the rotation to be here, so I won't lock it, and I will select. And now I will use the same mate I used earlier, which is width. So I want this to lie in the middle. That's why I will select this face this face, then simply another two faces, like this. Once you're done with this subassembly, save it, and let's go back to the master model, and here you can see it. Now let's rebuild the model and try to see the motion once again. Now we need to insert this once again, so you can classify them by type, and here you will find all the assemblies so you can reach it faster. This one, I want it to be here too, so I will start with concentric. I will select this face with this one and leave it for now, and let's insert the other piston. This one here, and this time select concentric, select this face and this one, and now once again select concentric, select this face and select this one. And finally you need to select advanced mate, go to width, and here I can select the inner faces because they are symmetric, and I can select this one and this one, and it will be right in the middle. Then hit OK, and here we still need to modify this dimension and this one, because obviously we have some problems. Now let's open this part, and for this sketch here, instead of 2.5 let it be 3.5. Then finish the sketch, and we need to go back and to measure the diameter we have here. So I will hide this part, then go to evaluate, and I need to measure this diameter, which is 6 millimeters. So I will go to the last part here, and I need to modify this revolve. So instead of 6, this should be 3. Then we need to modify this part. We need to drag this somewhere here, and then we need to define a radius of 0.25. Now save it, and let's go back here and let's show it, and now it's correct. Now let's try to see the motion. And let's try to check the interference once again. We don't have any interference, which means that our work is correct. Next, we will insert some pins here, and we will create an exploded view. Pins insertion and exploded view. As you can see, we don't have any pins that connect these two parts together or attach the cylinder to this plate. We need to make some measurements, then we can start the modeling, then we can insert them. So let's go to evaluate, measure, and here let's start with these pins. We need to measure the distance between these two faces, which is 30 millimeters, and we need to measure the diameter, which is 5. So we need to draw a 5 millimeter circle, and then we need to extrude this to 30. Now let's give it an appearance, and I will set it to black. Once you're done with this, save it, and let's call it displacer cylinder pin. And now let's go back to the assembly. And here I don't want to insert it in this assembly file. I want to insert it on this subassembly. So I will open this subassembly. And here, insert component, displacer cylinder pin. And here we have it. Now select mate, select this face with this one, and let's lock the rotation. And then select this face and this one. Now we have it placed, and we can simply select circular component pattern, and you can select this face. So we have an axis of revolution somewhere here, and we need 6 copies of this. And for the component, simply select this one, then hit OK. And here we have it. Now rebuild, and make sure to save this subassembly, then exit. And here, when you go to the master module, you will find them placed. We need to do the same, but this time with the support. So go to evaluate once again, measure, and let's measure this distance. We are interested in the Y distance here, as you can see, which is 13 millimeter, and we need to measure this diameter, which is 4. So we need to create a pin 4 in diameter and 13 in length. Now let's set this to 4 millimeters, and let's extrude it to 13. Finish the command, and here we can simply select paste appearance. Now we will call this support pin, and we need to close this part, and here insert component, and let's find support pin. Select mate, this face with this one. Now as you can see, you need to drag this a little bit here, and this face with this one. We didn't lock the rotation, so what you need to do now is to open this mate here and edit this feature, then lock rotation. Since we only have 4 components, we need to select this part, copy with mates, and here for the concentric I need this one, and I need to repeat this one. Hit OK, and let's do the same here. This one and this one will be repeated since it's selected here, and finally you need to do it here. Then exit the command, and here we have them placed. Before exploding the view, let's model and assemble the flywheel. To do so, let's start a new part file, and here on the front, let's start a sketch. We will start with a center line somewhere here, and then you need to draw an eye shape. I will set the first dimension, which is 3 millimeters, and I need to set these to be vertical. And now you need to create the following. You need to set these 2 points to be vertical, and this height to be 3, and this length to be 3, and the overall height is 40, and then set these to be equal, and set these 2 points to be vertical, and we need this distance to be 1.5. Now let's draw a center line somewhere here, then select mirror entities, and let's select these items, and let's mirror them about this center line. Then finish the sketch, and here select revolved, and for the axis of revolution select this center line, then hit OK. and then start a new sketch on the right. And let's start with a center line and another one. And here we need to place a circle, and we need this diameter to be 15, and we need this length to be 31, and we need to define an angle here of 15.5, and then select mirror entities, select this circle and mirror it about this center line, and finally finish the sketch and select extruded cut, and then select through all both, then hit OK, and let's give it an appearance here. So we can go to appearances here, and you can select painted, sprayed, and we can select this appearance, for example, then hit OK. And now let's save this file and call it flywheel. Now, when we go back to the master model, we need to insert this part and search for flywheel here. Then select mate, concentric, and here we need to lock the rotation because this flywheel will be rotating with the crankshaft as one unit. Now, after doing so, we need to place it right in the middle of this segment here. So under mate, advanced mates, you will find width, and here you need to select this face and this one, and then simply select this face and this one. And now, if you try to rotate it, it will rotate. Lastly, we need to place some pins here. So we need to select evaluate, measure, and then select this face. If you can't select it because it's transparent, simply remove the transparency for now, and then select this face. And then select measure once again, select this face, and select this one. And the Y distance here is 8 millimeters, and this diameter is 4. So I will open this part, and I will select save as, copy, and open. I will call it power cylinder pin. You can select close the original document, and here instead of 13 I will select 8. Then we need to save it once again, and let's insert it here. Search for power, and then select mate, select this face and this one, lock the rotation, and then select this face and this one. And when you're done, select circular component pattern, then select this face, and for the component select this one and increase the number to 4 and make sure it's 360 and equal spacing is selected. Now we have everything ready. Let's rebuild and save. If you try to rotate it, it rotates, and we have the motion we want. Now we need to go to exploded view, and here we need to select the components. I will start with this support. I will drag it somewhere here, then done. Or to make it in a good way, I will specify this distance to be 150, then done, and then I will select this bearing and I will move it 130 and in this direction. Then select done. After that, I will select this one, drag it somewhere here, and it will be 150. And then the bearing, and it will be 130. After that, I will drag this flywheel somewhere here, and I need this to be 110. And then I will select this part, and I will drag it somewhere here, and I need this to be 120. And I need to drag this too, and I want it to be 120, the same. Then let's drag the crankshaft, and I need this to be 60. After that, let's drag these pins here. When you select all of them, you can drag them at once. So I will drag these, and I want this to be 80. And then I will select these pins, drag them somewhere here, and set this to 80. And I need to drag this cylinder somewhere here, and I will set this to 60. And then this part, and then this one, and finally I'll select this one, I'll drag it somewhere here, then done, and here hit OK. Now if you go to Configuration Manager, under Default, open this and double click Exploded View and click it once again, you'll have this view. If you right click here, you'll find Animate Collapse, and here you have it. You can change the view mode to this one. And you can slow the play. More than that, you can save it as a video file. You can control the size and the aspect ratio. So for now, I will keep the same options. I will hit save. Now, select it once again, and let's view the file in video format. So select Stirling here, double click, and here you can see it. So basically, you can control the length of the video by stopping the animation. Now, I will click Default, and here we have the assembly ready. Rebuild it and save it, and this completes this part of this section. Next, we will talk about detailed drawing. Detailed drawing. Now we need to create a detailed drawing for this engine. We need to create it for every part, but here we will show the concept of the bill of material. So open this arrow here and select Make Drawing from Part Assembly. And here, let's select DIN A3, then hit OK. So here you have two options. The first one is to insert the model from here, from Drawing, Model View, or simply click here and you will find all the views. You will find the name here of your file, and if you don't find it, you can browse it, and once you find it, it will be listed here with all the possible views. What's good about this option here is that you can find the isometric exploded view. So I will put this here, and once again I will just have the, let's say, the isometric somewhere here. Now you can change the display to shaded with edges, and you can select this view here, and then you can change the display. Now you can click here and you will find 3D drawing views, and here you can rotate this view and you can rotate this one if you want to. It will make more sense this way. And as we earlier saw, you can change the scale. So instead of 1 to 2, you can make it, for example, let's say 1 to 1. As you can see, they are both connected. Like whenever you move one of them, the other one will move. To break this relation, select this one, right click, you will find alignment, and here, break alignment. Now, if you try to drag this, it moves alone, and this moves alone. Now, let's go to annotation, and here you will find auto balloon, select it, and then select this view. Then, let's drag this a little bit here. And here you have all the parts listed. You can drag these, or simply you can drag this line, which is like a magnetic line, so everything will be connected to it and everything will be in a good shape. You can drag this line here and here. You can expand it. If you select the arrow itself, you can expand it. And here I will expand this one after setting it in the right position. And for this one, I will keep it here. Now we need a bill of material, so we can relate it to these items. So you can go to Insert, Tables, Bill of Materials. And then you can select this view. In our case, I need to select parts only. And then hit OK. And here you have this list. As you can see, it's a big list. Here, as you can see, this view is very big. So I will select this view and I will go down until I find Scale. And I will set this to 1 to 5. And now you can drag it somewhere here. And you can place this table somewhere here. Dealing with this table is the same as dealing in a table in Microsoft Excel. For example, you can click here and then select Delete. I don't want this column, so delete column. And then you can drag it. And what's nice about this is that you will find each number here, like let's say number 1. This is number 1 here. And the name for it is Displacer Cylinder Bottom Plate. So this is the importance of naming every part in a proper name. And here's the quantity. Here are the pins. So number 4, let's search for number 4. Here's number 4. So number 4 is the displacer cylinder pin and the number is 6. And so on. Here are the quantities and here are the names of each part. So this is how we insert a bill of material and how we add balloons. In some cases, you will need to send your design to someone who doesn't have the software, so he cannot view it. SolidWorks offers some nice option here. If you go to the master model, here, if you go to Save As, and under Save As Type, you will find PDF. And here, you will find Save as 3D PDF. And select this option, view PDF after saving, then hit Save. And here you can view your design in a 3D inside the PDF. Here, 3D contact has been disabled. You need to enable this. So trust this document always. And once you click here now, you can see that you have your model in a 3D. You can rotate it. You can zoom to it. You can have sections. You can change the appearances. You can change the light type. And you can change the view. you have many options here. So this is a good way to share your model with someone who doesn't have the software. So he or she can view it in a 3D and can see all the details. So this course is presented for those who never used SolidWorks before. In the first section, we introduced the principle of the 3D modeling and we toured the interface. In the second section, we started with creating 2D sketch entities. And in the third section, we started modifying and dimensioning these entities. In the fourth section, we started talking about what we call sketch-based features. So we were able to create 3D models. And in the fifth section, we talked about other 3D tools, like how to define a material and how to measure the mass. In the sixth section, we talked about assembly design, which requires being able to create 3D models, and we already did that in the previous sections. In the seventh section, we talked about detailed drawing and how to make 2D detailed drawing so you can share them with manufacturers, managers, suppliers, or anybody who is interested in the drawing. And the last section, section 8, was the practical part of this training course. We modeled, assembled, and made some detailed drawing of a Stirling engine. This completes this training course. I hope you find it useful, and I'll be happy to answer all of your questions throughout the course. Thank you.